in the PDF? This one?
Oh, I forgot. So.
Okay, fine. So I'm giving you guys revise these things, and I'm giving you guys 10 minutes would be fine. At least do a few. I'm giving you guys 10 minutes. Do these questions, okay? Do these questions. Matthew, did you do this? 5 questions, Matthew?
No, sir, not all.
चलिए कीजिए, है ना? 10 minutes. Please do these questions.
Sure.
Yes, guys, done. Yes, Aisha done. How many of you are done with the first question, guys? Please raise your hand now. How many of you are done with first question? Nobody's done with the first question. Raise your hand if you're done with the first one. Okay, Samaira, Matthew. Okay, Sarah, Aisha. Okay, Zainab, what happened? Zainab, can you please turn the mic on? Achha, you have got, okay. Can you write the name of the product that you have got? Can you write the name, or you are confused a bit? Those who have got the answer, they try to write the name of the product, okay? Try to write the name of the product. What about the second one? Raise your hand. Second one, how many of you? No one is done with the second one. Okay. Second one, no one is done. Okay, then third. How many of you are done with the third one? No one. Fourth question, how many of you are done? Okay, Matthew is done with the fourth. Sarah is done with the fourth one. What about fifth? Okay, Aisha is also done. What about fifth, guys? Keep your hand raised if you're done with the fifth one. No. Okay. Oh. Actually, I did a mistake. ये तो आप लोगों से नहीं होगा. Let me write the products here. CH4 and here it will be CH3. CH3. Now try the second and third one. Sorry, huh? I have to give here the products. I think I gave it, but then I erased it right now. Okay. So for A, what is the answer for A, Aisha? What is the name of the product? Speak. Don't write, don't type. Speak, huh? बताइए.
So will it be CH3, CH2, CH2, CH3?
And name.
Name I'm not sure.
Name you're not sure? You did organic chemistry with us, yes or no? Nomenclature, Aisha?
No.
No, you're not doing. Okay. How many carbons did you get? Tell me. In the product? I hope you got 6 carbons.
Yes, sir.
6 carbons, that means it is hexane. Okay. Now in the fourth structure, you would have got cyclopentane that is attached with another cyclopentane. And in the fifth structure, you make the structure twice. And where there was bromine, so here was bromine and here there was bromine. So you just add these two. So this is the structure that you will get. So the name for this will be, this is our parent. And the name will be, what will be the name? 1, 2, 3, 4. Methyl and methyl 2, 3, 4, 5. 2, 3, 4, 5. Tetra. Two, 3, 4, 5 tetramethyl. 2, 3, 4, 5, 6 hexane. Please look in your notebook and then tell me what are A and B. What are A and B? This is bicyclopentane. And bicyclic products, you will not be asking me for bicyclic products. But if you have two cyclic molecules which are attached through a bond, those are bicyclic products. So you just name bicyclopentane. The complete name is something like this, that it is 1,1' bicyclopentane. But if you refer this to bicyclopentane, then it will be fine. Tell me about A and B. What are A and B? What is the reagent that should be used to go from a salt of carboxylic acid to 1 carbon less than to 1 carbon?
Water.
Yeah, correct. Soda lime, NaOH plus CaO, calcium oxide. What about B? What will be B? Sorry, same name. देखिए अलग है ना? No,
Okay.
these are different things, na? Can you look at, see the products? They are different. Flip your notes, guys. You are not reading notes. Please read the notes. You'll not get anything if you don't read the notes in organic chemistry. Sab ud jayega, because there is a lot of information going on right now. And each and every reaction is important, okay? Done? What is B? Tell me. Guys, you please don't take so much time now. You just look at the notes. Preparation of alkenes, look at the notes. You have to at least understand how to look at the notes. Na? Same question ही कराया होगा हमने notes में आपको. ये देखिए आप. Same question. Now we have acetate ion and CH3 is forming. What is this? Coal-based reaction, electrolysis. It is electrolysis. Right, today's topic, physical properties of alkene. Please start studying, guys, okay? At least you should know what is present in your notes and where it is present. Right, physical properties. Physical properties of alkene. Right, number 1, boiling point. Boiling point. Boiling point will depend on the intermolecular forces of attraction in alkene and alkanes. These are what? Alkanes are non-polar substances which have weak van der Waals forces. So since alkanes are non-polar, they have weak van der Waals. So I'll be referring van der Waals as VDW, weak van der Waals force of attraction. Forces of attraction. And hence their boiling point are low. Therefore, hence their boiling point are low. Next point. Now, boiling point increases, boiling point in alkanes increases with increase in carbon number, increase in carbon atoms. We have also seen why. Why does it increase? Because we have more number of carbon atoms, there will be more electron distortion will be possible. And then, wait a second. Yeah. So in alkanes, what happens? We have more number of carbon atoms, that means more electron, and more electrons means more electron distortion. If you remember some parts of states of matter that I asked you guys to read and come, please, you can look here. This is states of matter, right? Now, while we were learning about, it was your van der Waals forces of attraction, hydrogen bonding, London force dispersion forces. Okay, so London force dispersion force is other name of van der Waals forces. So if you see here, size increases, electron distortion increases, and there is increase in van der Waals forces. Okay, there is increase in van der Waals forces. Hence, we say in hydrocarbons also, if the number of carbon atoms increases, the boiling point is going to increase due to the increase in van der Waals forces. Next is boiling point decreases with increase in branching, because if you branch something, then it becomes more and more spherical, and as it becomes more and more spherical, it takes less and lesser area, and if it takes less area, that means the size is going to be smaller, and if the size is smaller, distortion of electron is not very much possible. Distortion of electron is not very much possible. So this is the this is the boiling point properties. Next is melting point. Right, next melting point. Now, again, melting point also, what will happen with melting points? It will also depend on the intermolecular forces of attraction. But there is one anomaly seen, that alkanes with even number of carbon atoms have higher melting point as compared to the immediate odd ones. Okay, the immediate odd ones. It does not mean that if I will have methane's melting point will be greater than that of ethane. It does not mean that. Okay, what does it mean? See, there will be some increase if I go from methane to ethane, and if I then go to propane, CH3, CH2, CH3. So let us say this was X. So I'm going from odd to even. Then I'm moving from even to odd. I'm moving from even to odd again. So let us say the difference between these two is Y. The difference between these two is Y. Now, what does it say? It says that the difference between odd and the next even, that is X, it will be higher than Y. So when I move from even to odd, I am expecting a very high increase in the melting point, but it is not present. There is a very less difference between even and the next even carbon atom and the next odd carbon atom. The difference between these two is going to be very less. Okay, so Y is very minimum. So even and the next odd is going to be somewhat same. So what is our expectation? Our expectation is that I'm going to get a high melting point if I move. But if I move from even to odd, we are not getting that much high melting point. But if I move from odd to even, the jump is very high. The jump is going to be very high. So relatively, as compared to the immediate odd ones, okay, as compared to the immediate odd ones, not, it is a relative increase or relatively higher. It is not absolutely higher. Relatively means when I compare the increase in the melting point from odd to even and even to odd. Next point is melting point increases with increase in carbon atom, with increase in carbon atom. Next point. Even members of alkane are tightly packed due to the terminal carbon on opposite sides of zigzag structure. Okay, see. Okay, then I can have so it is like perfectly aligned. Structure is like this, so it is perfectly aligned. If I have an odd number, then it is either going to be like this, so there is no joint. But if I see here, look, we make alkanes like this. So as you can see, these two things, they are locking the carbon atoms. But if I have odd number of carbon atoms, then it is either going to be like this. Okay. Or like this. So that is why, since they are having terminal carbons that are on the opposite corners, hence the packing is going to be more effective in even number of alkanes in the solid state. So in melting point, what do we have to see? We have to see the intermolecular forces of attraction also, and we also have to see the packing. How is the packing? Is it effective or is it ineffective? So even members have effective packing, and the terminal carbons are on opposite side of the zigzag structure, which gives the tight packing. Next is solubility. Solubility. Now, thumb rule for solubility is, please write this. Don't write, but whenever you are going to write this, make it very important. This is the thumb rule. Like dissolves like. Okay, that means polar dissolves polar, non-polar dissolves non-polar. Okay, so polar substance will dissolve polar substance, non-polar substance will dissolve non-polar substance, and that is why alkenes, they are not very much miscible or soluble in water. So alkenes are not soluble in water since they are non-polar, and water is polar solvent. How is water polar solvent? You have oxygen bonded to hydrogen, so hydrogen will have delta positive, oxygen will have delta negative, so there is a polarity like this, right? So this is a dipole. There is a dipole present in water molecule, that is why it is polar. Alkenes, they are not polar, and that is why they cannot interact with polar molecules. So alkenes, if they will not interact with polar molecules such as water, so they will also not get dissolved in alcohols. So alkenes are also not soluble in alcohol, since alcohol also are polar. You have R OH. So O will be having delta negative. This will be having delta positive. Okay, so that is why it is going to be not soluble. So alkenes are soluble in non-polar solvents. Alkenes are soluble in non-polar solvent. Non-polar solvents such as benzene, hexane, ethers. Okay, so these are non-polar solvent and alkenes are soluble in them. Alkenes are soluble in them. Next is the chemical properties of alkenes. No doubt in physical properties, right, guys? Tell me, any doubt in
No,
physical
sir.
properties?
No, sir.
Okay. So next we want to have the chemical properties. Chemical properties. Okay. Decide the question, why are alkenes less reactive? Why are alkenes less reactive? So whenever you have to talk about reactivity, so alkenes are less reactive. That means what are they asking? When alkenes are on as reactants, they are not very good reactants, right? They don't react very well. Yes or no? If I'm talking about reactivity, tell me, guys.
Yes, sir.
Hmm?
They don't react.
No, they don't react. That means when you have alkenes in, if you have alkenes, let us say C. So they don't react. Okay, there is any reagent here. They don't react well. So if these are not reacting well, what does that mean? I cannot break any bond from the reactant, because whenever we have a reactant, what happens with the reactant? Bonds of the reactants are broken. Yes or no? From reactants, what
Yes.
happens? Bonds are broken, right? Very good. When bonds are broken, so what are the things that will lead to easy breaking of bond? If the bond enthalpy is low, I hope we have learned thermodynamics. In that we have bond enthalpy. If the bond enthalpy is low, that means it will be good and they will react very easily. But if we have any molecule whose bond enthalpy is high, that means we have strong bonds. That means they are not going to react very well. They are not going to react very well. Now, one of the properties that determines the strength of bond is the polarity. For example, if we have OH bond, right, and here we have a high delta negative and high delta positive, then we can say that most of the electrons are towards oxygen, and this bond can break very easily. This bond can break very easily. Okay, but if I look at carbon and hydrogen, this is a non-polar bond. Both of them have relatively similar electronegativities. Both of them have relatively similar electronegativities. So in alkenes, we have either CH bond or we have CC bond. Now both of these single bonds are what? Both of these sigma bonds are very, very strong, and that is why we cannot break them. First thing is that alkenes do not have any polar bonds. This is the first reason. Next is the CC bond and CH bond have high bond energy. Or you can also write the CC bond and CH bonds are very strong bonds. Very strong sigma bonds. Okay. So the sigma bond of CC and CH are very strong. So this is the two reason. This is the two reason why alkenes are less reactive. But so if we have alkenes which are less reactive and we have to break the bonds, that means we have to give more energy. As any like they will not give the reactions only. They will never react. Less reactive means at normal conditions, at room temperature and all, they will not react. Normal conditions. They don't react at ambient conditions, that is 25 degrees Celsius and 1 atmospheric pressure. So we have to give drastic conditions. We will have to give some condition, special condition, in order to react them, in order to make them react. So the first type of reaction, that is the first class of reaction that we have to study, is substitution reaction of substitution reactions. Substitution reactions, what happens in substitution reaction? We have A bonded to B, we react this with C, and then we get A which is bonded to C. A which is bonded to C. So B is substituted by C. B is substituted by C. This is the simple plain definition for substitution reactions. Now in substitution reaction, what will happen with our alkenes? We will have RH, right? R is alkyl group and hydrogen. If you add, okay. CS3 is what? Methyl. If I add hydrogen, this will become methane. So that is why generally we show alkenes as RH. R is the alkyl group plus H, plus there will be some, let us say there will be some reagent. Okay, let us say R to hai hi aapke paas yahan pe NEA, and it is going to replace the hydrogen from the alkyl group. Okay, the hydrogen from the alkyl group. So this type of reaction you will be seeing. First type of reaction is, first reaction in this is halogenation. Halogenation. Now in halogenation, the simple reaction is you have RH plus sodium. Halogenation, so X2, sorry, X2. I was thinking about Wood's reaction. We have alkane plus X2 in the presence of light or heat, in the presence of light or heat, and you are going to get RX. So hydrogen is replaced by halogen and you get HX as byproduct. HX is byproduct. Now, why is this light and heat? Light and heat. So if you remember, helper. Okay, so this is what? You remember this, guys? This word helper or no? Electricity, light, or peroxide. If you have any of these, then it is going to give you free radical. It is going to give you free radical as an intermediate. Free radical as an intermediate. That means halogenation. Halogenation is happening via free radical mechanism or via the formation of free radical. So we can write a statement: when alkenes are treated with halogens in the presence of helper. Okay, in the presence of helper, that means any one of these things. The presence of helper, they form corresponding alkyl halides. They form corresponding alkyl halide. So I'm giving you reactions. CH4 plus Br2, the presence of H nu, that is light. And H nu means what? H nu means a wave of light. Okay, a wave of light. We are going to form CH3 Br, CH3 Br plus HBr. So I'm giving you two more questions. Please write the products. Okay, so in one of the in the B question, you have to write the product, and in C, you have to give me what is the reagent that we will be using.
Done.
What about others? Samira, done?
Done, sir.
So in B, you will be getting CH3, CH2, Cl.
Yes, sir.
And in A will be Cl2.
Cl2.
Cl2 in the presence of H2. Okay, now we know that we can have a reaction, and in the reagent, we can either use F2, we can use also Cl2, we can use Br2, and we can also use I2. Now, what is the rate of reaction? Rate of halogenation. If I compare the halogens, if I'm going to compare the halogens. Now, if I am going to react CF2, then I am going to make CF bond, okay, and HF bond, right? Because here there will be CF bond, carbon and fluorine bond, and then we'll be making HF. If I talk about Cl2, then we'll be making CCl and HCl. Here we'll be making CBr and HBr. Here we'll be making Ci and HI. Now, if I compare these bonds which are formed, and if the products are very stable, that means the rate of reaction will be high. So if I compare the bond strength of the product, so CF bond, this is what? 2p bond. Carbon is also 2p in the second period, and fluorine is also in second period. This is second period, third period, second period, fourth period, second period, fifth period. So I can see the bond strength is like this, right? So the bond strength is somewhere like this, because 2p, they will have much higher effective overlapping than the carbon iodine bond, and hence I can say that the order of reactivity will be F2 will be most reactive, Cl2, then Br2, and then I2. Now F2 is so reactive, that it is explosive. And I2 is so less reactive, and it is so slow that it is reversible. We will talk about these 2 points later on, but as of now, I'm going to keep it here also. And now we'll be looking at what happens if I have CH4. If I have CH4 and I treat this with, it's small. Cl2 and H nu, then I will be making CH3Cl. Then if there is excess of Cl2 and we have the light source, then one more hydrogen will be replaced, and we will be getting H2Cl2. Furthermore, if we still have Cl2 remaining and H nu, then we will be getting HCCl3. And furthermore, we can also get CCl4. So this reaction does not stop. Until and unless all the chlorines are attached on the carbon atom. All the chlorines are exhausted, or the chlorine is finished, completed. Okay. So reaction does not stop till all the X2 is consumed. Okay, and that is why they give, this reaction gives a mixture of haloalkanes. So if I look at this haloalkane, this is mono substituted. That means only one substitution has taken place. This is di-substituted haloalkane, tri-substituted haloalkane. This is tetra-substituted haloalkane. Gives a mixture of haloalkenes with different number of halogen atom. Now, since we are going to get mixture of haloalkenes, this is not a preferred method of preparation for haloalkenes. This is not a preferred method of preparation for haloalkenes. Okay, let us write the mechanism now. Now, in mechanism, what we will see a simple reaction of CH4 with Br2 in the presence of, let us take Cl2 only. Br2 is going to be sometimes slow. Cl2 in the presence of H nu, which is going to give me CH3Cl plus HCl plus HCl. So in the first step, what is going to happen? This reagent, which will be more reactive than the substrate, that is CH4. So in the first step, the chlorine-chlorine bond in the presence of H nu, that is light, it will break like this, homolytic fission, and we will get Cl free radical plus Cl free radical. So in second step, one of these Cl free radical, it will attack on one of the hydrogens of carbon. Okay, so any of the hydrogens of the carbon can be attacked, and here we have Cl free radical. Cl free radical. So Cl free radical will attack like this, and the hydrogen will come up with its own one electron, and they will form a bond forming HCl, and the carbon will be left with CH3 free radical. CH3 free radical. In the last step, what is going to happen? Now, furthermore, this CH3 free radical, now what it can do? CH3 free radical, and if we have two chlorine atoms, so this CH3 free radical will attack on chlorine. Chlorine will come up with its one electron, and they are also going to form a bond, and then you will be getting CH3 Cl plus Cl free radical plus Cl free radical. The third step, in the third step, you will have all the free radicals, CH3 free radical, Cl free radical will combine. Cl free radical plus Cl free radicals can also combine. Now CH3 free radical plus CH3 free radical can also combine. They can also combine. Okay. So if I combine CH3 free radical and Cl free radical, I'm going to get CH3Cl, and this will be giving me Cl2, and this will be giving me CH3CH3. Okay, although this will be very minor, because you can see that this step is happening two times. And CH3CH3 free radical is happening only one time. So this will be very minor. Okay, this will be in minor amount. This will mean minor amount. Okay. So the first step, in which, as you can see, the Cl free radical from here, the Cl free radical from the first step is acting as the reactant in the second step. Okay. Then we have CH3 free radical, which is acting as a reactant again. And here we have Cl free radical and CH3 free radical, which are acting as the reactant in the next step. So it is kind of a chain reaction. So the first step is known as the chain initiation, because we are initiating the chain initiation. Now, a very good measure of checking or of identifying the chain initiation reaction is, will have a neutral atom and it will be giving you 2 or more free radicals. Okay, from neutral to 2 or more free radicals. Then next we have chain propagation. Chain propagation. Now in chain propagation, you will have 1 free radical in the reactant, and there will be 1 free radical which will be other than the reactant free radical. So here we have Cl free radical, but in this case we are going to have CH3 free radical. In the other reaction of chain propagation, we have CH3 free radical, but the product is Cl free radical. Okay, last is termination. Last is termination step. Now in termination, what happens? We will have free radicals on the reactant, and there will be neutral products in the product side. Okay, there will be neutral substances in the product side. Okay, so these are the 3 steps. Now important point is that, to note, free radical is formed. Free radical is formed in this reaction as intermediate. Now, if we have free radical as intermediate, then the stability. If I want to talk about the stability of free radical, and that will determine the rate of reaction, and hence the rate of reaction directly proportional to stability of intermediate. Stability of intermediate. Now, if I take a carbon like this, CH2, CH3, and this carbon also has 1 hydrogen here. This carbon has hydrogen here. Now, both of these hydrogens are reactive. They can react in the presence of any X2 molecule, let us say Cl2 molecule, in the presence of H2. Any of these 2 hydrogen atoms can be broken. Any of these 2 hydrogen atoms can be broken. Now, let us say that not any, both will be broken. Some will be broken more easily, some will be broken less easily. Okay, some will be broken more easily and some will be broken less easily. Now, if I talk about these 2 hydrogen atoms, this is a bit small. So if I talk about the blue hydrogen, then it is first of all going to form CH2 free radical, CH2 and CH3. If I talk about the red hydrogen, then it is going to give me CH3, CH free radical and CH3. As you can see, this is 1 degree, this is 2 degree. If I talk about the stability of these 2 free radicals, in this I can say there is a hyperconjugation because this is sp2. This is alpha carbon and alpha hydrogen. It is equal to how much? 2. What is the number of alpha hydrogen here for this carbon? This is sp2. What is the number of alpha hydrogen? How many alpha hydrogens are here?
One.
How many alpha hydrogens are here?
1, right?
6.
Oh, wait, never mind. 6. Sorry. Wait.
पढ़िए भैया, पढ़िए आप लोग. 1 or
Yes, sir.
okay. So obviously, which is more stable? This free radical is more stable, and that is why this is going to give you a product in which you will have CH3, CH, CH3, and the chlorine will attach on this carbon atom, right? Because free radical will be, you will have Cl free radical. So Cl free radical will attack here like this, and these 2 will be forming bond like this. Okay. So this will be the major product, and this will be my minor product. That is CH2. There will be chlorine attached here. CH2 and CH3. CH2 and CH3. So there are 2 things. First of all, we are going to get 2 products in this case. We are going to get 2 products in this case. So you have to identify in the reactions how many products are you going to get. Okay, how many products you are going to get. So you can write a question. Identify the number of products, number of monochloro products. Okay, monochloro products given by the following. If I have simple butane, so I can say that these two carbon atoms are same. Yes or no? And these two carbon atoms are same, correct?
Yes.
Yes or no, guys? No or yes? Kya ho gaya?
Yes, sir.
Right? These are the carbon atoms which are same. They don't have any difference. If I talk about the red one, this is also 2 degree, this is also 2 degree. And this 2 degree is attached to 1 degree, this 2 degree is also attached to 1 degree, this 2 degree is also attached to 2 degree, this 2 degree is also attached to 2 degree. If I look at the chemical environment, all of these are same. So the hydrogens which are here, they will also be same. And if I talk about here, there are 3 hydrogens here, and there will be 3 hydrogens here. Okay, so we can either react the red, this hydrogen, or we can either react this hydrogen atom. Okay, we can react the hydrogen atom of red carbon or the blue carbon, and we are going to get 2 products only. Okay, we can get either Cl 1 degree, or we can get a 2 degree Cl. Just something like this. So monochloro product, how many? 2 monochloro product. Second question. If I look at this pentane, so all of the carbon atoms are same here. Yes or no? Tell me. All of the carbon atoms are same. Correct?
Yes.
All of them are connected ना. देखिए आप लोग, ये आप लोग को देखने आना चाहिए. How to see? Okay, please tell me if you have any difficulty in identifying whether all the carbon atoms are same or different. What about here? Are all the carbon atoms same in this case? I have a methyl group attached. Are all the carbon atoms same here? Okay. Sarah, can you please speak? Turn the mic on.
Yes, sir.
Yes, tell me, are they same or different?
Different.
Different. Okay. All the carbon atoms are different. So can you tell me how many different carbon atoms are there? How many
One,
different? Eh? Only one is different.
as in total.
Total?
One is different.
Only one is different. Others are same. Yes, Sarah, yes or no?
Yes.
So you're saying this is different? Everything else is same?
Yes, sir.
Is my voice lagging, Sarah?
No.
So why you are taking so much time? देखिए आप लोग, यही आप लोग को आइडेंटिफाई करना. What about others? Aisha, tell me. We have 6 carbon atoms. You have to tell me which of them is different and which of them are same. Aisha, tell me. Yes, Aisha. No idea. I can't hear you. Samaira. Samaira.
Yes, sir.
Which is different, which is same? Don't know.
One is different.
Others are same?
Yes.
Achha, it seems same. Okay. So what is the degree of one? It is primary, secondary, or tertiary. 1 degree, 2 degree, or 3 degree.
Primary.
Okay. What about this one? The second carbon. 1 degree, 2 degree, or 3 degree. Sara, you tell me. Keep your mic on, all of you. नहीं. Why you guys take so much time? यार time नहीं आप लोग को पता है ये चीज. उसके बाद भी आप लोग. Keep your mic on. Matthew, Aisha, Samaira, Zainab, Sara. Yes. This blue carbon is 1 degree, 2 degree, 3 degree, 4 degree.
4 degree.
Can you please speak loudly, Sara? यार वो इतना एकदम कान लगा के सुनना
4
पड़ जाता है
degree.
आपको. 4 degree. What about others? 2
No,
degree.
3.
पढ़िए भाई आप लोग पढ़िए. आप लोगों ने तो हाँ ज़ैनब यू आर राइट करेक्ट 3 डिग्री. 3 बॉन्ड है 3 कार्बन से अटैच है 3 डिग्री. ओके व्हाट अबाउट दिस नेक्स्ट वन. नेक्स्ट वन
2 degree.
4 डिग्री. फिर 4 डिग्री कौन बोल रहा है?
2.
2 डिग्री. हाँ 2 डिग्री. व्हाट अबाउट दिस वन?
Again.
2 डिग्री. अब यहाँ पे ध्यान से सुनिए आप. Listen very carefully. Now you can see that at least 3 different carbons are there. This black carbon is different than the blue carbon, and this blue carbon is also different from the red carbon. Yes or no?
Yes, sir.
Yes.
You can see that. Okay. Now let us see whether this sandy, I don't know what color is this. This color, this carbon. Let me make it green. Green will be better. Yes. Whether this green carbon and this orange carbon, these are same or are they different? Tell me, they are same or different? Looks same. They look same. Okay, but you have to see. They look same, but you have to see. If I look at this 2 degree carbon atom, if I look at this 2 degree carbon atom, then it is attached to one 3 degree and it is attached to one 2 degree carbon atom. Okay, it is attached to one 2 degree carbon atom. But if I look at this 2 degree carbon atom, it is attached to one 2 degree and it is also attached to another 2 degree. So this 2 degree is attached to, this 2 degree has structure which is like this. Now this 2 degree has a structure which is like this. So these two are different, obviously, because their connectivity is different, na? Yes or no? Tell me.
Yes.
Yes, sir.
Right. The other thing is that the other way of looking, which are different, which are same. You have a methyl group here. आप क्या कीजिए यहाँ पे क्लोरीन लगा के देखिए, नाम लिखिए इसका. You write the name. Then you attach chlorine here and then write the name. Okay. Then you attach a chlorine here and then write the name. Then you attach a chlorine here and then write the name. You will be getting different names. Okay. Then you attach a chlorine here. So if you attach chlorine here or here, they will give you same name. Okay. They are going to give you same name. If you attach a chlorine here or here, it is going to give you same name. That means these two are same. These two are also same, but this is different. This one is different. And we also have this carbon, which is different, which this carbon is different. So there are total how many carbons in this? We have 1, 2, 3, and 4 carbon atoms. Okay. We have 4 carbon atoms. So we will take this case next. But as of now, in cyclopentane, if I talk about cyclopentane, this is only going to give me either the chlorine will attach here or any of the 5s, right? Or here, or here, or here, in any one of them. Okay, in any one of them, and you will be getting chlorocyclopentane. But if I look at this structure, then it is going to give me acha Cl2 H nu, here also Cl2 H nu. By the way, this will be more stable, right? Major product, because it is 2 degree, है ना? 2 degree free radical बना होगा इससे. Here we are getting only one thing. That means we don't have to talk about major product or minor product. In this case, you will be getting either the Cl can attack on the hydrogen which is on that carbon atom, or you can get a product like this, or you can get a product like this. or you can get a product which is having chlorine here. Okay, now in this case we have 4 products. Who can tell me which is major? A, B, C, or D? Which is going to be major?
Is it A?
How are you saying A?
Because it's on a tertiary carbon.
A. ये tertiary है. Look at the carbon atom, where it is attached, the chlorine.
Yes, sir. It's primary.
Look at the carbon atom and tell me. Okay, A carbon is what? 1 degree, 2 degree, 3 degree.
1 degree,
1 degree. B is 2 degree, 3 degree, 1 degree.
3 degree,
C is 1 degree, 2 degree, 3 degree.
2,
D,
2,
which will be most stable? Which will be most stable, guys?
3.
3. 3 तो है ही नहीं option में.
I mean 3
A,
degree.
B, C,
I
D.
mean B.
B, yes. So B will be major. Got it, guys? Yes or no? Tell me.
Yes, sir.
Okay. So this is going to be your homework. Please write this down as I'm writing, okay? Write all the products for following and identify the major product and name all of the products. Name all of the products. Okay, we have CS3, 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 which is attached to one here carbon hydrogen. Okay, there is carbon. Write these 3 questions. Okay. Please do the homework. Okay, write it. Done, guys? You wrote the question?
Yes, sir.
Now, another question is regarding the rate of reaction. So, which of the following? Arrange. The following in decreasing order of rate of halogenation. Okay, so we have 3 compounds given. This is simple. Butane, this is A. Have iso butane, and here we have CH3, CH3. Then we have CH4. So obviously, we will see that which of the carbon atoms. So what is the maximum degree? So here we have A has the maximum. A has 1 degree carbon and 2 degree carbon. So the maximum is 2 degree. Here we have 3 degree carbon available. This carbon is 3 degree. Here we have only 1 degree, and this is what 0 degree, and this is what 0 degree. So obviously, B is going to be fastest because if we have 3 degree free radical, that is going to be more stable. And if intermediate, we are forming intermediate fastly, we are going to get product fast. So B followed by A, followed by C, and then followed by D. So in general, we can write rate of halogenation. Now, when I'm comparing here, what the substrate now, we have compared the reagent F2, Cl2, Br2, I2, and that F2 is going to be fastest, and after that Br2, and after that, sorry, after F2, Cl2, Br2, and then I2. And in halogenation, when we are comparing the substrate, that is the alkene, and 3 degree is going to give you the fastest reaction, followed by 2 degree, and then followed by 1 degree, and then followed by the CH4, that is 0 degree. CH4, that is 0 degree. Okay. Next is, let us say, if we have quaternary carbon, for example, this carbon, CH3, 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 and CH3. So even though this carbon is what 4 degree carbon atom, it is not going to give halogenation. This carbon is not going to give you show halogenation. You'll be getting monochloro product by these 4 carbon atoms. All of them are 1 degree, and all of them are same. Now, since this carbon does not have any hydrogen, that is why it will not replace hydrogen. Hydrogen, what will it replace? Okay. So this carbon atom that is 4 degree, it is not going to show you halogenation because of absence of hydrogen atom, due to the absence of hydrogen atom. Okay. Now next, write 2 note. First thing is that the first thing is F2 and I2. Yeah. Reaction with F2 is so explosive that it breaks CC bonds too. Next is reaction with I2 is reversible since HI is a good reducing agent. So what happens? We react CH4 with I2 and any alkene with I2. So it gives me CH3I plus HI. Now this HI bond is so weak that what happens? H plus is liberated and H plus attacks on CH3, and then it again forms CH4. So this is what? This is reversible. Now, if I want to form iodoalkene or alkyl iodide, CH3I, then what I have to do? I have to remove this HI. And if I will remove this HI, that means I am removing the product. If the human is removing the product, then the equilibrium will shift in the forward direction, right? Yes or no? You remember this, right? From equilibrium. What happens if we remove the product? याद है कि नहीं याद है? भूल गए. Guys, you remember, if I remove the product, then I am decreasing the amount of product. If the human is decreasing the amount of product, then the system or the system will be trying to increase the amount of product. To increase the amount of product, it will shift the equilibrium towards forward direction. Yes or no?
Yes, sir.
Yes.
Yeah, okay. So this is how we apply equilibrium, the Chatler principle. So what we need to do, we need to remove this HI. How should we remove this HI? Since this HI is what? Reducing agent. What I will do, I will add an oxidizing agent, and an oxidizing agent will react with the reducing agent HI, and then the HI will be removed slowly. HI will be removed slowly. Okay. So that is why strong oxidizing agent such as HNO3 or HiO3 is added which converts HI to I2 and the equilibrium is shifts in forward reaction, forward direction. So in the container, two reactions happen after after the addition of HiO3. So we have CH4 plus I2. It gives me an equilibrium reaction. Here we have CH3I plus HI, and we have added HI and HNO3, let us say. So HNO3 reacts with HI and it leads to the formation of, it gives H2O plus NO2 plus I2. So in this case, like we have hit this, like we have used two arrows. We have removed the product. We have also increased the amount of reactant molecule, that is I2. And that is why this reaction becomes completely, it shifts completely towards the forward direction. Okay. The first reaction, CH4 plus I2. Okay. Then we have the next type of reaction, that is combustion. In combustion reaction, we have two types of combustion reaction. That is, either it will be complete or it will be incomplete combustion. So you have burnt paper, right? Yes or no? You must have burnt paper. Paper mostly have carbon molecules. So if you completely burn, if you have complete combustion, so combustion, that means reaction with oxygen. Okay. So you can either have complete or incomplete. So if you have complete combustion, if something is burned completely, then you will only get carbon dioxide will be liberated plus H2O will be liberated. Okay, water vapor. But if you burn something and there is incomplete combustion, so you will be leaving some carbon. And the black bach jata after the ashes, no? Those are carbon, complete carbon solid, and you will be getting water molecule. This is the incomplete combustion. This carbon is known as carbon black. Known as carbon black. Okay. Known as carbon black. Now this is combustion, that is a reaction with oxygen. It can be also called oxidation, but alkenes have oxidation, that we do some controlled oxidation in order to prepare different type of molecules. So next is controlled oxidation, or rather to say controlled oxidation of alkenes. The previous one was combustion. This is controlled oxidation. Controlled oxidation. Now, if I have carbon molecules, that is alkenes, let us say CH4, and I treat this with O2 in the presence of copper, hot copper, we say hot copper or hot red copper, that is copper at 500 Kelvin and 100 ATM. Then we are going to form CH3OH, that is alcohol. Then we get alcohol molecules. So you can balance this by 2 here and putting 2 here, I guess. Second is, if I have any alkene, I react this with O2 in the presence of M2 molybdenum oxide M2O3, then I get aldehyde. If I have CH3 plus O2 and I treat this with a complex of acetate CH3 COO whole twice with manganese, then I get carboxylic acid CH3 COOH. Fifth reaction is, if I have any alkane such as this and I react this with KMnO4, then I get the most stable kind of alcohol, that is 3-degree alcohol. Okay, so if I have like plus KMnO4, it is going to give me 2-degree alcohol. Okay, next reaction, that is reaction with steam. Steam means water in gaseous form. Okay, and gaseous form and also at high temperature. Steam, it will be very hot. Steam will be hot. So reaction with steam. We take alkane CH4 for example and react this with H2O gas with Al2O3 as a catalyst. You also call this Al2O3 as alumina at 1273 Kelvin to get carbon monoxide, plus we get hydrogen gas plus H2, plus we get hydrogen gas when we react this with steam. Now we have two more reactions. Isomerization. So most important reaction was your halogenation reaction, in which you will get question, and this reaction, the controlled oxidation, you may also get questions from here. So you have to learn the reagents. So if you have copper, you get alcohol. If you have molybdenum oxide, you get aldehyde. If you have acetate and manganese, then you will get carboxylic acid. If you have KMnO4, then you are going to get alcohols. Okay, you are going to get alcohols. More substituted alcohols. Next is isomerization. In isomerization reaction, if I have a long chain alkane, let's say, for example, if I have butane and I react this with AlCl3, the presence of HCl, that means we need some acid in the presence of heat, then it will isomerize, it will form its chain isomer. But if I take, for example, pentane, then pentane is also going to form isomers such as 2-methylbutane. It can also form 2,2 dimethyl propane, and what else it can form? Yeah, 3 isomers only, na? Yes, 3 isomers only. Okay, now this is isomerization. Next is aromatization. So in this we have the reagents are, the reagent is, we have alkane with at least with 6 or more than 6 carbon atoms. Okay, with 6 or more than 6 carbon atoms. The reagents, let me write the reagents that we use, the catalysts. You can use vanadium oxide, Cr2O3, or you can also use molybdenum oxide, that is MO2O3 at around 800 Kelvin, that is high temperature, and 10 to 20 atm of pressure. Now, if you have 6 carbon, then you are going to get benzene. If you have more than 6, then you are going to get alkyl benzene. That means, let us say, if you have hexane and you react this with, in the presence of V2O5 high temperature and pressure, then you will be only getting benzene like this, simple benzene. But if you have 7 carbon atoms, let us say, in the presence of same things, V2O5, then with the 6 carbon atoms, you will be making benzene, and one of the carbon atoms will be as it is. So you'll get methyl benzene or toluene. And this is what methyl benzene or toluene. Okay, this is toluene. For example, if you have 1, 2, 3, 4, 5, 6, 7, 8, then you are going to get ethyl benzene. From the 6, you are going to create benzene, and the other 2 carbon atoms will be as it is. This is ethyl benzene. So ethyl benzene. Last reaction is the decomposition of alkanes. The decomposition of alkanes, that is, what will happen if I heat it with some good catalyst, okay, with some catalyst. So write as pyrolysis or decomposition. Decomposition of alkanes. So what is happen? So on heating with suitable catalyst, alkenes form, alkenes and smaller alkenes. So basically they break down. For example, if I have a simple CH3, CH2CH3, that is propane, you will be seeing this word pyrolysis written. Then it is going to make CH3, CH double bond CH2, plus it can also make CH2 double bond CH2. It can make CH3 single bond CH3, plus it can make CH4. So whatever lower alkenes are present, smaller alkene, it can make them. So you don't have to worry about what are the exact product of pyrolysis. It can be many. It can be many. So you just need to remember. That it is going to form alkenes and smaller alkenes. It will never give you higher alkenes. So we cannot start with propane and do the pyrolysis and expect to get butane. Okay, so you're not starting from 3 carbon and expecting 4 carbon atoms. Okay, so this is the last reaction. Next thing that we have to study is conformers. Okay, next thing that we have to study is conformer. Okay, conformer. What is conformer? So for that you have to wait a second. Can you see this screen now? Different screen?
Yes, sir.
Yes, okay. This is methane. Sorry, this is ethane. I'm just let me rotate this thing first of all. चलिए ऐसे ही बनाऊंगा. Okay, so this is the ethane molecule. Now there are 2 carbon atoms, right? There are 2 carbon atoms which have hydrogens attached to it, and there is a certain way in which the hydrogens have aligned themselves. Yes or no? Tell me. This is the most stable state for ethane. Can you see this? That they have aligned themselves in a certain way. Yes or no? The hydrogens,
Yes,
right? They have aligned themselves in a certain way that they are they are diagonally apart. If I talk about this hydrogen and if I talk about this hydrogen, they are diagonally apart. Similarly, this hydrogen and this hydrogen are completely apart. Okay, this and this has like they are very apart. Now, let me try to rotate it. Let me try to rotate it. So I hope I can rotate it. Which yes. Yeah. Now I have changed the position of hydrogen atoms. Correct, guys? Yes or no? You can see that.
Yes, sir.
Yes. So we have changed the position of hydrogen atom. Now let us try to stabilize it. Let us try to see, is this form most stable or is some different form most stable? Now I will do the stability part really slowly so you can see the change, how this ethane molecule likes to stay, how this ethane molecule likes to stay. So I'm starting this. So this is slowly moving. Now please remember, single bond, in single bond the rotation is allowed. That is why it can rotate so easily, right? So actually this bond is moving. This bond is moving. And I think we have achieved. Now I don't think we can see any change. Can you see any change, guys?
No.
So equilibrium aa gaya. So we can stop the reaction. Now we have achieved equilibrium. So this is the stable state, right? And if I try to do it again once more, okay, let me just try to rotate it once more. Okay. Not this bond. This bond is rotating, that bond is rotating, not that one. This is this one. Okay. So I hope this is fine. So let me try this again. I hope get the same result. So yeah, again, they are trying to make themselves in such a way that the hydrogens are far apart. The hydrogens from both the carbons, they are far apart. Fine, I think we have achieved stable state. Fine. Now these two forms of alkenes, these two forms of alkenes, we call them conformers or we call them rotamers, because when we rotate it, we get those different conformers. Okay. So now we also know that ethane, it likes to stay in a particular way. It likes to stay in this particular way rather than the previous way, how we have rotated it. So we will talk about these two things. So the topic will be conformers. Conformers. So how can we define conformers? Different arrangement of atoms in space obtained by rotating along carbon carbon single bond, carbon carbon single bond. So first thing is that if I make molecules like this, CH3, CH2, CH3. Now this representation of okay, we were talking about ethane, so we'll talk about ethane only. CH3. This representation of ethane is not going to show me the conformers. So we have to try and we have to make a new type of representation of molecules that will show us different conformers. Okay, so representation of conformers. How are we going to represent it? Representation. So one of the representation is this one that we just saw. Okay. It was something like this, yes or no? Tell me. Yes or no, guys?
Yes.
Hydrogens were like this, no?
Yeah.
Yeah. So Newman, there was a scientist Newman. He made up a representation of conformers. So this representation is known as the Newman projection. Newman projection. So we are trying to look at alkene from a different perspective. We are trying to look at alkene from different perspective. So he said that the front carbon atom, there are two carbon atoms in ethane. We have CH3 carbon and then CH3. So he said that what will happen if I rotate it and I try to look through this carbon atom. So this carbon atom is in the front. So that will be represented by dot. And the hydrogens attached to it will be directly linked to this dot. Okay. Like this. The hydrogens are here. The back carbon will be represented by a big circle. And the hydrogens will be like this. So we saw this conformer. Okay. And the other was the hydrogen like this. There's a circle around it. This is the back carbon. And the hydrogen were eclipsed. It was kind of a eclipse that the front hydrogen, they were eclipsing the back hydrogen. So these are the two conformers that we saw. This is known as eclipse form. This is known as the eclipse form. And this is known as the staggered form. Staggered form. This is the eclipse form. So this carbon atom, that is the dot, front carbon. This big circle is the back carbon. The angle between these two in the staggered form, they will be same, that is 60 degrees. All of them will be 60 degrees. So this angle is known as the dihedral angle. It is equal to 60 degrees in the form of staggered. But if I talk about this hydrogen between the angle between the hydrogen of two different carbon atoms, the angle between hydrogens of two different carbon atoms. So this angle here, dihedral angle, will be equal to 0. It will be equal to 0. There is one more projection that was given by Sawhorse. This is not Sawhorse, sorry. It looks like Sawhorse. That is why it was named as Sawhorse projection. Second is Sawhorse projection. Now in Sawhorse projection, you have a slant line. Like this. Wait a second, I need to take this. Yeah. Then you'll have two hydrogens like this. And if you have hydrogens in the opposite way, so you can see this is down, this is up, this is going downward, this is going downward. These two are going upwards. This is again the staggered form in Sawhorse projection. This is staggered. This is staggered form. And then you can also have the similar thing. I could not get the line. I needed the line, by the way. This is the eclipse form. This is the eclipse form. Okay. This is Sohor's projection, Newman projection. Then we talk about the stability of Sohor and the eclipse form. Stability of staggered and eclipse. Sorry. Stability of staggered and eclipse form. Okay, and this is for ethane. This is for ethane. So obviously staggered is going to be more stable. Why staggered is more stable? Because the hydrogens are far apart. Hydrogens are far apart. And dihedral angle is maximum. Dihedral angle is maximum. Next is in eclipse. There is a repulsion between hydrogens of both carbon. Hydrogens of both carbon, which leads to instability. Which leads to instability. Okay. Now we are at alkenes. So this is all about alkenes. Then we have alkenes now. We have alkenes now. Okay. Now in alkenes, how can we identify alkene? It has at least one double bond. Okay, it has at least one double bond. What is the general formula? It is CN H2N CN H2N. Then the smallest member is what? Smallest member CH2 double bond CH2. These are also known as AKA olefins. It is also known as olefins. Next is structure and bonding. Structure and bonding. So if I look at a carbon atom which is part of alkene, that it has a double bond. It will be carbon, double bond, and there will be two single bonds. So obviously I can say the steric number that is equal to the number of sigma bond plus lone pair. The number of sigma bond is 3. Hence the hybridization will be equal to sp2. If hybridization is sp2, we have geometry. This will be trigonal planar. And the shape will be also trigonal planar, as there is no lone pair. Trigonal planar. And what is the angle here? Angle will be 120 degrees. Angle will be 120 degrees. One more thing is that due to the presence of pi bond here, due to the presence of a double bond, pi bond, so pi bond are weaker than sigma bond. That means pi bond can break, and if pi bond will break, it is going to give you electrons. And if it is going to give you electrons, that means it can act as nucleophiles. So we can say alkenes are electron rich. Alkenes are electron rich and can attack on electron poor sites. Can attack on electron poor site. That means they can act as nucleophile. Okay. Next is nomenclature. So in nomenclature, I will give you only one question that you have to try. CH2 double bond, carbon, CH2, CH2, CH3, whole twice. Okay. So I'm giving you guys 2 minutes. Try to make the structure first. Okay. Try to make the structure from here. In NCERT, you will not get bond line structure. You will get this type of condensed structure. You will have to convert it to bond line or the skeletal. So write this down. We will try to name this. Yeah. Did anyone crack the structure? Aisha, Matthew, Samira, Sarah, Zainab. Huh, guys? No. Okay, fine. So first of all, we will look at the non-bracket ones. Okay. Non-bracket ones, you can directly write H2, carbon, double bond, carbon. Now this carbon is attached to this group. Okay. This carbon is attached to this group, and how many times? 2 times. For example, if I said, let us say CH2 double bond, CH2, that means there are 2 times hydrogen. Would have made the structure like this. Right. Similarly, you will make the same thing. You will attach CH2, CH2, CH3 one time, and again CH2, CH2, CH3 another time. Okay, so this is the structure. Now let us talk about the functional group. Those who have learned from me, उन्हीं को समझ में आएगा. E, the unsaturation. What is the unsaturation, guys? The functional group is E because there is no functional group. Then the unsaturation. Yes, Samira.
En.
What is it? En. Parent. What is the parent? Samira and Sarah. Expecting answers from you. Terminal bataiye. We have A terminal, we have B terminal, and we have C terminal. Where should I start from?
A.
A terminal. Very good. Then I'm at a junction. Where should I go? Towards B or towards C?
Any.
Any. Very good. Now, how many carbon atoms? 5. So pent, yes or no?
Yes, sir.
Right, guys? Now, anything that is remaining after the identification of functional group, unsaturation, and parent is substituent. So this is our substituent. How many carbons in the substituent, guys? How many carbons in the substituent?
3.
3. That means prop and YL to represent that it is a substituent, that it is a substituent. Now comes the numbering. Where should I number from? A or B? Where should I start numbering? From A or from B?
A.
Very good. 1, 2, 3, 4, and 5. 4 and 5. That means propyl is in second carbon atom. So this will be 2-propyl, and En is at 1. So this will be 1-ene. So we name it 2-propyl pent 1-ene. You can also write this 2-propyl pentene, है ना? So usually one you can write it or not write it. There's a choice, but I usually write it because I have to be consistent with the numbering part. Okay, so I try to be consistent with that. So I will say that better write this. You will never make mistake, है ना? Rather than trying to write 2-propyl pentene. Okay, what about others? Zainab, Matthew, and Aisha, you got this? Yes or no?
Yeah, sir, I got it.
Okay, fine. Now, if you want to learn IUPAC nomenclature, now if you want to learn IUPAC nomenclature, then you can, I have uploaded some videos. You can go to SHR Chem. Okay, but in that now I have used Hindi and English mix. You can go to SHR Chem. There will be a playlist, IUPAC nomenclature made simple. Okay, IUPAC nomenclature made simple. So you can write this name. If you Google it, there is, I don't think there is any other channel, SHR Chem. So you can just look it and play it in 2x or 3x. You will get the idea. So the main idea is this part, that functional group, unsaturation, parent, and substituent. So please write this. Now moving on. Moving on to isomers. Okay, moving on to isomers. Achha. Okay, I will tell you structural isomers. So first thing is that alkenes show both kind of isomerism. Alkenes show structural as well as stereoisomers. So let us talk about structural isomers. Stereoisomers I will talk in the next class. Structural isomers. So we'll start with CH2 double bond CH2. There is no other way of arranging these two carbon atoms. That means this will have no structural isomer. Moving on, CH3 single bond CH double bond CH2. Again, I can make another structure, that is CH2 double bond CH2, sorry, CH2 double bond CH single bond CH3. But I will ask you to say whether it is same or different. Think about it, whether it is same or are they different. I have changed something. You have to tell me whether it is different or same. I cannot change the arrangement. We all know that. Then next we have, if we have 4 carbon atoms and there will be 8 hydrogens. So the first simple structure that I can make is CH2 double bond CH single bond CH2 single bond CH3. Okay, this is going to be But 1-ene. Secondly, I can also have CH3, which is bonded to CH, doubly bonded to CH, and again CH3. You can count the number of hydrogen atoms. It is going to be 8, and this is But 2-ene. Now I can also do one thing, that is I can reduce the chain length and I can make it CH2 double bond carbon single bond CH3. There is a CH3 which is attached to this carbon atom also. Now in this case I have got 2-methyl. But 2-methyl prop 1-ene. 2-methyl prop 1-ene. Okay. Now I cannot make more structures here, but I can see that there are 3 structural isomers, and the relationship between A and B is that we have no difference other than the position of the double bond. That is why these are position isomer. Position isomer. Those guys who have not done organic chemistry, I just want to remind you that we have done the functional group isomers. What else is there? Position isomers. I know. So these things have already been done. Chain isomer or skeletal isomers. Okay. So you can go back and look at the video. See, But 1-ene, But 2-ene, same thing. butadiene. So alkene will show position isomers. If I talk about B and C, they are what? Here we have but and here we have prop. That means there is a change in the chain length, and that is why these are chain isomers. Skeletal isomers. Similarly, A and C are also chain isomers. Okay, chain isomers. So tomorrow, when do you guys come tomorrow? कल आप कितने बजे आते हैं? Yes, guys.
8.
You come at 8 o'clock, no? Fine. So you will come at 8 o'clock. 8 o'clock में आते हैं आप लोग?
No, sorry.
8 or 8? हाँ, सारा?
9, I guess.
9. नहीं
I'm not sure because I just started last week on Tuesday and Thursday.
हाँ नहीं ये तो इंडियन टाइम तो हमको पता है. You all come at 9 o'clock. I know that. Okay.